Evaluation of definite integrals by substitution. We have learned how to integrate functions, and also we have learned sometimes substitution is required. So in that case, uh, we are changing x in terms of say t or in any other variable. But in the case of definite integrals, when we are doing substitution, we have to take care also that we have to change the limits also, because the limits are in terms of x. Suppose we are integrating the function in terms of x. Suppose we are having a function fx in terms of x, and we are integrating that in respect to dx. Then if you do not change the limits, then the limits will be still in terms of x, and the remaining function will be in terms of say the other variable, say t. So our answer will be incorrect. So let us see how it is to be performed. So we will be going exercise 7.10, and let us do question number 1 to study this method. So solving question number 1, solution 1. Here we have I equal to integration of 0 to 1 x by x square plus 1 dx. One method is that we can separately solve integration of x over x square plus 1 dx, and then whatever answer we get later on we put the limits. Or other one is directly we can use the substitution method. In that case, we will not separately solve this function of x over x square plus 1, but we will use the substitution method, and in that case we will change the limits also, because here the limit is x equal to 0 and x equal to 1. Lower limit is x equal to 0 and upper limit is x equal to 1, and we are integrating the function in between those limits. So let us see how it can be done. So let x square plus 1 equal to t. Therefore 2x dx will be equal to dt, and therefore we can say that x dx equal to dt by 2. Now therefore we can write I equal to 0 to 1. Now what is our x dx? That is dt by 2, and x square plus 1 is t. So if we write like this, then it will be incorrect. So this will be incorrect. Why incorrect? Because the limits are still in terms of x, so this is incorrect. So what we'll do, we'll even change the limits also. So let us do that the correct way. The correct way is, before doing the substitution, we'll change the limits also. So let's do that one. So we will say that when x is equal to 0, this implies t is equal to, just put the value 0 square plus 1, that is 1, and when x equal to 1, this implies t will be equal to 1 square plus 1, that is 2. So therefore I equal to, now we'll integrate the correct way. I will be, our integration initial was from 0 to 1, but now since we have done the substitution and we have taken x square plus 1 as t, that means our new variable is, we are integrating this function in terms of t. So we'll write here lower limit is 1. When x is 0, the value of t is 1, and when x is 1, the value of t is 2, and remaining we'll do the substitution. X dx is equal to dt by 2, so half we can take out, and dt is there, and over here we are having x square plus 1, and x square plus 1 is t, so we'll write here t, and now we can easily integrate. So it's very simple. Let us make it small. So this is 1. We know that the integration of 1 by x is log x, so we'll be getting here equal to half log modulus of t, and the limits are from 1 to 2, and care is to be taken that we have not to convert this back in terms of x, because if you do that, then this will be incorrect, because the limits are in terms of t. So now solving this, equal to half log, we will be getting here 2 minus log 1, and we know that log 1 is 0, so equal to half log 2. So this is the answer of question number 1, exercise 7. question 2, exercise 7.10. Integrating from 0 to pi by 2 the function root sine phi cos raised to 5 phi d phi. So let us solve question number 2. Solution to I equal to integration of the function root sine phi cos raised to 5 phi d phi from 0 to pi by 2. So this will be solving by taking substitution method, so it will be easier for us because we know that difference of sine phi is cos phi, and that is already here. So but before that we'll do some changes, because if suppose we take sine phi as t, then here we'll have to convert this cos in terms of sine. Very simple. So therefore let us write I equal to 0 to pi by 2 root of sine phi, and cos we can write as this as cos is to 5 phi as cos is to 4 phi into cos phi d phi. This implies therefore I equal to 0 to pi by 2 root of sine phi. Now we'll convert this in terms of sine, and we can write this as sine square phi, not sine square phi but 1 minus sine square phi, 1 minus sine square phi raised to the power square 2 cos phi d phi. Why? Because we know that this can be written as cos square phi whole square, and we know that cos square phi is 1 minus sine square phi, because cos square phi plus sine square phi is 1. So now let us do the substitution. Let sine phi equal to t, and let us this be 1. Therefore we have cos phi d phi equal to dt. Also now the limits are in terms of phi, so we'll convert that in terms of t. So when phi equal to 0, this implies t is equal to cos 0, sorry, t equal to, that is sine, we'll just put the value here. So t equal to sine 0, and that is 0. And when phi is equal to pi by 2, this implies t is equal to, we'll put the value of pi by 2 in this, that is sine pi by 2, and it will become 1. Therefore we can say what is our I. Therefore I equal to, limit has changed now from 0 to 1, so 0 to 1, and here in place of sine phi we'll put t, so we'll write here root t, and this will become 1 minus t square whole to the power 2, and cos phi d phi will become dt. Therefore I equal to, integrating from 0 to 1, this will be writing as t raised to half, and this will become 1 plus t raised to 4 minus 2t square and dt. Why? Because the expansion of x minus y whole square is x square plus y square minus 2x12. So therefore I equal to, integrating from 0 to 1, this will become t raised to half, then plus this will become 4 plus half, that is t raised to 9 by 2 minus 2, and 2 plus half, that is 5 by 2. So and dt here, so we'll be integrating this one, so we'll be getting therefore I equal to, we know that integration of x raised to n is x raised to n plus 1 over n plus 1, so half plus 1, 3 by 2 over 3 by 2 plus t raised to here also 9 by 2 plus 1, so that is 11 by 2 over 11 by 2, and minus 2. We'll be getting here, here we have not written t, so that t will be coming, so this is t raised to 5 by 2. The power 5 by 2 is over t and not 2, so minus 2t t raised to, this will be 7 by 2 over 7 by 2, and limits will be from 0 to 1. So now we'll simplify this one. So we'll be getting, therefore I equal to, this will become 2 by 3 t raised to 3 by 2 plus 2 by 11 t raised to 11 by 2 and minus 4 by 7 t raised to 7 by 2. So therefore I equal to, now we'll put the value of 1 first. So we'll be getting here 2 by 3 plus 2 by 11 minus 4 by 7, because putting t as 1 in this will give the value as 1 only, because 1 raised to any power is 1 only, and remaining next time minus, if we put the lower limit, we'll be getting because t is multiplying with 2 by 3 here, so t raised to 3 by 2 is multiplying here, so t power something is multiplying with 2 by 11, and here also t power 7 by 2 is multiplying with 4 by 7. So overall we'll be getting here 0 when we put that value of t as 0. So finally the answer which we'll be getting here will be equal to, therefore I equal to, let us take the LCM of this. So here we'll be getting 2 into 11 into 7 plus 2 into 3 into 7 minus 4 into 11 into 3 over 3 into 11 into 7, and so this will give us 22 into 7, that is 22 into 7, let us multiply it. So this will give us 154, plus similarly this will give us 42, and this will give us 44 into 3, that is 12, 1 carried over 132 over here we will be getting 77 into 3, so 77 into 3, that is 21, 2 carried over 21, so that is 231, so 231. Now equal to, so let us first solve this 154 and 132. So 152 minus 132 will give us 20, and 2 more, that is 22 plus 42. So 22 plus 42, that is will give us 64 over 231. So this is the answer of question number 2. Question number 3, integrating from 0 to 1 sine inverse 2x over 1 plus x squared dx. Solution 3, I equal to integrating from 0 to 1 sine inverse 2x over 1 plus x square dx. We will be solving this by substitution method. So let us take x as tan theta. Let x equal to tan theta, because we know that 2 tan theta over 1 plus tan square theta is sine 2 theta. So sine inverse and sine will cancel each other. So therefore this will give us dx equal to sec square theta d theta, and let this be 1 and this will be 2. So putting 2 in 1, and before that we'll have to change the limits also. So when x is equal to here when x is equal to 0, in that case what we can say that this implies tan theta equal to 0, and this will imply theta equal to 0, because we know that tan 0 is 0. Also when x equal to 1, this implies tan theta equal to 1, and from this we'll have to obtain the value of theta, and we know that tan pi by 4 is 1, so theta equal to pi by 4, and let this be 3. So putting 2 3 in 1, putting 2 3 in 1, we have, so let us see what we will have. We'll have I equal to integrating from 0 to pi by 4 sine inverse, this will become 2 tan theta over 1 plus tan square theta, and dx will become sec square theta d theta. Therefore, I equal to 0 to pi by 4 sine inverse, and this will become sine 2 theta sec square theta d theta. So, I equal to 0 to pi by 4 2 theta into sec square theta d theta. So, now we'll solve this by integration by parts, and let us write down the rule. So, the rule is ILATE, I-L-A-T-E. Algebraic is coming first and trigonometric is coming second. So, that is already in order. No need to interchange here the functions. So, therefore, we'll be getting I equal to, let us put the limit as it will be integrating inside. So, that is 2 theta into integration of sec square theta d theta minus differentiation of 2 theta will give us 2 with respect to theta into integration of sec square theta d theta. So, sec square theta d theta and outside d theta, and this will close, and the limits will put from 0 to pi by 4. So, pi by 4. Now, therefore, we'll get I equal to 2 theta integration of sec square theta, we know that is tan theta, so tan theta, and minus here 2, then integration of sec square theta is tan theta, d theta is already there, and limits are from 0 to pi by 4. Next, therefore, I equal to 2 theta tan theta minus 2 integration of tan theta, we know that is log sec theta, log mod of sec theta, and limits are from 0 to pi by 4. So, now let's put the values and check what answer we get. So, therefore, I equal to 2, our theta is from here, theta just will put the value 2 into pi by 4, and 10 pi by 4 minus 2 into log sec pi by 4 mod is there, then we'll put the lower limit in this, and this will give us minus, so putting the value of 0 wherever theta is there, so 2 into 0 into tan 0 minus 2 log sec 0, and so therefore what we are going to get is I equal to, this will give us pi by 2, 10 pi by 4 is 1, so pi by 2 into 1 minus 2, and log sec pi by 4. What is log sec pi by 4? That is equal to log of root 2 and bracket closed minus, here we are having minus, and we know that sec 0 is 1, so this is minus 2 into this will become, because log 1 is 0, so this becomes 0, and finally we'll be getting I equal to pi by 2 minus 2, this over 2 the exponent will be 1 by 2, so that 1 by 2 we can take out of the logarithmic function, so it will be getting 2 into half log 2, so 2 and 2 cancel, equal to pi by 2 minus log 2. So this is the answer of question number 3. Question number 4, integrating from 0 to 2 the function x into root of x plus 2. So solution number 4, I equal to integrating 0 to 2 x into root of x plus 2 dx. So whenever we are having square root or any root, we must try to remove that one. So the best thing we can do is put x plus 2 as t square. So let us do that. Let x plus 2 equal to t square. Therefore, we will be getting, differentiating both sides with respect to uh, t, we will be getting this as this will become 2t dt equal to this will become dx. So now also we'll change the limit also. So when x is equal to 0, in that case this implies, we'll put the value of x equal to 0 here. This implies t square is equal to 0 plus 2. Therefore t equal to, we'll take plus root 2, because here we can see that the limits are increasing from 0 to 2. T equal to root 2 will not take a negative value. Then let us take the next case. When x is equal to 2, this implies t square is equal to let's put the value here. X equal to 2 implies, we'll put the value in this. So we'll be getting this will give us 2 plus 2 equal to t square. Just what we have to do is just put the value of x equal to 2 here. So we'll be getting this as 2 plus 2 equal to t square, and here we have written this 0 plus t, not this is not 0 plus 2, this is not t, this is plus, we add that plus to this. It is not to be confused with that. Let me rewrite this one. 0 plus 2, this is not t, it is plus. Now moving back in our step, so we have got here 2 plus 2 equal to t square. Therefore we can say that t square equal to 4, or we can say that t equal to 2. Again we will not take minus. Now we'll just put these values in I and see what we will be getting. Therefore I equal to, changing the limit now, when x is 0, t is root 2, so root 2, and when x is 2, t is still 2, and what are the function we will be getting here is in place of x, x we'll have to write that, we can write as in terms of t square minus 2 into, and this will become x plus 2, we have taken as t square, so that is root of t square, and dx is 2t dt, 2t dt. So therefore we can say that I is equal to root 2 to 2, and this is t square minus 2, this is t into 2t, is 2t square dt. So therefore I equal to 2 we can take out, and root 2 to 2, this will become t raised to 4 minus t square, because we have taken this t outside. So this will become minus, here 2 is the minus 2t square and dt. So I equal to 2, when we integrate this we will be getting t raised to 5 over 5 minus 2 t cube over 3, and the limits are from root 2 to 2. Now we'll just put the values and see whether what answer we are going to get. Therefore I equal to, first putting the upper limits, upper values, so we'll be getting 2 multiplied by 2 raised to 5 over 5 minus 2 into 2 cube over 3 minus 2, this time we'll be putting taking t as root 2, so root 2 raised to 5 over 5 minus 2, this will become root 2 cube by 3, and now we'll simplify this. Therefore I equal to 2 into, so this will become 32 by 5 minus this will become 8 into 16 by 3, and minus 2 is there, so this will become root 2 into root 2 is 2, and again root 2 into root 2 will become 2, and one more root 2 is there, so this will become 4 root 2, 4 root 2 by 5. Similarly, this will become 2 root 2, and this 2 is there, so this will become minus 4 root 2 over 3. So now let us calculate this further. Therefore, I equal to 2 into, from both we can take out 16 common. So from here we will be getting 2 by 5 and minus 1 by 3, minus same here we can take out 4 root 2 common. So it becomes 8 root 2, 1 by 5 minus 1 by 3. So therefore I equal to 32 into this is 6 minus 5, that is 1. So into 1 by 15 and minus 8 root 2, and this will become 3 minus 5, that is minus 2 by 15. So therefore I equal to 32 by 15, and this will become plus 16 root 2 over 15, and from both we can take out 16 by 15 common. So remaining will be from here 2 plus, and from here what will remain is root 2. So therefore uh, I equal to 16 by 15, 2 plus root 2 is the final answer of question number 4. Question 5, exercise 7.10. Solution: I equal to integrating from 0 to pi by 2 sin x over 1 plus cos square x dx. So from the function itself we can easily see that if we substitute cos x as t, we'll get the answer. So let's do that. Let cos x equal to t. Therefore, we'll be getting minus sin x dx as dt, or we'll be getting equal to dt, or this implies sin x dx is equal to minus dt. Now let us change the limit. When x is equal to 0, this implies t equal to cos 0, that is 1, and when x equal to pi by 2, this implies t equal to cos pi by 2, and that is 0. Therefore, we have I equal to, putting the limit now, lower limit is 1 and the upper limit we are getting is, after changing the doing the substitution, we are getting 0, and sin x dx, that is equal to minus dt over 1 plus cos x is t, so 1 plus t square, and that is equal to, we know the integration of 1 over 1 plus x square is 10 inverse x, so we will be getting here equal to, minus we can take out, so that is 10 inverse t, and from 1 to 0 equal to minus, and this will give us 10 inverse 0 minus 10 inverse 1, and that is equal to minus here 10 inverse 0 we know that is 0, and 10 inverse 1 we know is pi by 4, so minus pi by 4 equal to this will become pi by 4. So the final answer of question number 5 is pi by 4. Question number 8, exercise 7.10. Integration of integrating from 1 to 2 the function 1 by x minus 1 by 2x square e raised to 2x dx. Now we have already learned the function of the type here e raised to x fx plus f dash x integration of this dx. But the condition was that in that, if you see, the coefficient of e is to be x, but here it is 2x. So what we'll do, we'll try whether it can be solved in that form or not by doing substitution. So we'll take 2x as t, and integrate this, and then we can check whether it can be we can apply this form or not. So let us start doing this one. So solution 8, that is I equal to integrating from 1 to 2 the function 1 by x minus 1 by 2x square and e raised to 2x e raised to 2x dx. Now to check for this form, what we'll have to do, we have to make the coefficient of we have to write in this in the form of e raised to x. So we'll be taking 2x as t. So let 2x equal to t. Therefore we'll get dx equal to dt by 2, and also we change the limit. So when x equal to 1, t equal to 2. When x is equal to 2, this implies t equal to 4. Therefore we can say that I is equal to, changing the limits now, 2 to 4, 1 by x. In place of x, so what we'll be getting here, t by 2, or we can write here 2 by t, then minus 1 by 2, here also is x square, so that is into t square by 4, because x is t by 2, and e raised to t, and dx is dt by 2. So this is how we have rewritten our I. So dt by 2. Now let us simplify this further. So therefore I equal to, integrating from 2 to 4, this will become 2 by t minus, here also 2 and 4, 2 will cancel 4 and it will become 2. This 2 we can take up, it will become t square, and e raised to t, this half can take out, and this will become dt. Also we can take this 2 outside, so we will be getting, therefore I equal to, integrating from 2 to 4, 2 and 2 will cancel each other, so we will be getting half minus 1 by t square, half minus 1 by t square e raised to t dt. Let ft equal to 1 by t. Therefore f dash t is equal to minus 1 by t square. Therefore we can say that I is equal to e raised to t ft, and the limits are from 2 to 4. Why? Because if I is equal to integration of e raised to x fx plus f dash x dx form, then the answer of that is equal to e raised to x fx plus c. So this is the reason for which we have got the answer of this as e raised to t into ft, and limits are from 2 to 4. So therefore we can say that I is equal to e raised to t. Now what is our ft? Our ft is 1 by t. So 1 by t, and the limits are from 2 to 4. So that is what we'll put, equal to, therefore I equal to e raised to 4 by 4 minus e raised to 2 by 2, equal to, we can take out e square by 2 common from both, and what will remain here is e square by 2, and from here we will be getting minus 1. So this is our final answer of question number 8th one. Question 10, exercise 7.10, solution 10th one. So here we have fx equal to integration of the function from 0 to x. The function is t sin t dt. And now we'll solve this by because there are two functions involved, so we'll be solving them by integration by parts. So therefore we can say that fx equal to here first of all let us write the rule of ILAT. So we can see that a is coming first and t is coming later in this, so it's already in order. We can write this as I equal to t into integration of sine t dt minus integration of differentiation of t is 1 into integration of sine t dt, and here putting dt, and the limit is from 0 to x. Therefore fx equal to, we will be getting here t integration of sine is minus cos t, and minus here also we will be getting minus cos t, so it will become plus cos t, and the limit is from 0 to 1, is from 0 to 1, not 0 to 1, sorry, it is 0 to x. So we'll write here 0 to x. Here also we write down the same, this 0 to x, and therefore we can say that fx equal to this will become minus t into cos t, and plus here when we integrate cos t, we will be getting sin t. Now we'll put the limit, that is 0 to x. Now we'll put the limit, therefore fx equal to minus x cos x plus sin x, then putting the lower limit, so we'll be getting minus 0 into cos 0 plus sin 0. Now the second part will become 0, and we'll be getting, therefore fx equal to sin x minus x cos x. Now we need to find the value of f dash x, so we'll be solving this one. F dash x equal to cos x minus this x into differentiation of cos x is minus sin x, plus cos x into differentiation x is 1. So now equal to, therefore f dash x equal to, we'll be getting cos x minus plus x sin x, and this will become minus cos x. So plus cos x minus cos x will cancel each other, and the final answer will be, therefore f dash x equal to x sin x. So this will be our answer of question number 10. Now questions for self trial. So all remaining questions will be for self trial. Remaining questions for self trial. That is, you will try them on your own. So with this the exercise is complete.